guys, welcome back. This is Sakshi Kakade, and in today's session we are going to see what is hashing. So let's move towards the point that what is exactly hashing. So basically, hashing is a technique that is used to uniquely identify a specific object from a group of similar objects. For example, in libraries, each book is assigned a unique number that can be used to determine information about the book, such as its exact position in the library or the users it has been issued to, etc. Similarly, we can take the example of students studying in a particular university. That is, each student is assigned a particular number. That is, we call the number as PRN number. And we can say that the PRN number is the key through which we can find the particular student. So basically, hashing is a searching technique. Let's move towards the next point, that is, in hashing, large keys are converted into small keys by using hash functions. So we will see later on what are hash functions. The values are then stored in a data structure called hash tables. The idea of hashing is to distribute entries, that is, key value pairs, uniformly across an array. So each element is assigned a key. As in the example of students and university, I have told that the PRN number acts as a key, whereas the student is the object. So through the key, that is through the PRN number, I can find the particular student which I want. By using that key, you can access the element in big O of one time. That is, in a very less time you can find the objects. Using the key, the algorithm hash function computes an index that suggests where an entry can be found or inserted. Next, hashing is implemented in two steps. So the first one is an element is converted into an integer by using a hash function, and this element can be used as an index to store the original element, which falls into the hash table. Next, the element is stored in the hash table where it can be quickly retrieved using hashed key. So this is basically the hash function, that is hash equals to hash function of key and index equals to hash mod array size. So this is basically the hash function. Let's move towards the point that what is exactly a hash function. So basically, a hash function is a function that can be used to map a data set of an arbitrary size to a data set of fixed size, which falls into the hash table. So the values written by a hash function called hash values, hash codes, hash sums, or simply hashes. Let's further see what is hash table. So a hash table is a data structure that is used to store keys values pairs. It uses a hash function to compute an index into an array in which an element will be inserted or searched. Later on, with an example, we will see what is hash table and what is hash functions. So the next point is about collisions. So what are collisions? While converting large hash values to small values, index can be repeated. If two values give same index values, then collision occurs, and hence collision resolution techniques are used. This happens many times, so we use the collision resolution techniques. So let us see the first collision resolution technique, that is separate chaining, or it is also called as open hashing. So basically, what is it? Separate chaining is one of the most commonly used resolution techniques. Again, it is usually implemented using linked list. In separate chaining, each element of the hash table is a linked list. Again, to store an element in the hash table, you must insert it into a specific linked list. Then, if there is a collision, then store both the elements in the same linked list. Again, the hash function for separate chaining is that h of k equals to k mod m. So this is basically the hash function for separate chaining, where k is the key and m is the size of the array. So let us see this separate chaining with an example. Let us consider that I am having the key values as 550, 700, 76, 85, 92, 73 and 101. These all are my key values, that is k, and m equals to 7, that is size of my array is 7. So by separate chaining we have h of k equals to k mod m, where k is the key and m is the size of the array. So for the first key, that is 50, we will get h of 50 equals to k mod m. Again it equals to 50 mod 7, that is k is 50 and m is 7. So how can we get the mod value, that is 50 mod 7? So simply by dividing 50 by 7 we get the remainder as 1, and this remainder is basically the mod value. So the answer for this h of 50 will be 1. Again for h of 700, for the key value 700 we will get the value as 0. For key 76 we get the value as 6. Again for the value 35 we get the value as 0. So see, now in this case the value for key 700 and key 35 both are 0. So this is when collision occurs. But in separate chaining we are using linked list for that purpose. Again for the key 92 we get the value as 1. For key 73 we get the value as 3, and for key 101 we get the value as 3 again. So this is how my array will be, that is it will consist of 7 index positions, that is it will be from 0 to max minus 1, that is 0 to 7 minus 1, and it will be 0 to 6. So the first key 50 we got value of hash function for key 50 as 1. So we will put the value 50 at the first index position. For the key 700 we got the value as 0, so we will put the value 700 at the index position 0. For 76 we got the value as 6, so we will put that into the 6th index position. Now you can see that for 35 key we have got the value as 0, so we will give this value as a linked list at the index position 0, which will be connected to the value 700. Again for 92 it will be at first index position linked to the first key, that is 50. For 73 it will be at the index position 3, and similarly the linked list for it will be 102, which is linked to the value 73. So this is basically how separate chaining works. Let's move forward to the next point, that is linear probing. So what is it? In open addressing, instead of in linked list, all entry records are stored in the array itself. So the hash function for linear probing is h of k comma I equals to h dash of k plus I into mod m. So this is basically the hash function for linear probing, where again we can write it as h of k comma I equals to k mod m plus I and whole bracket mod m, that is we can write the h dash of k as k mod m. So this is the hash function where I is the index position, k is the key value and m is the size of hash table. So let's see this linear probing with an example. Let us consider that the key values for this case are 26, 37, 59, 76, 65 and 86, and m is the size of array. In this case the m size is 11, that is the size of array is 11. So by linear probing we are having the hash function as h of k comma I equals to h dash of k plus I. So for the first key, that is 26 key, we have considered the 0th index position, and for that value we got the value as 4. Again in the next case for value 37, in the first case for the index position 0 we got the value as 4, but you can see in this case that for key 26 we have also got the value as 4, and for 37 also. So this is basically collision occurs. So for this case we have taken the next index position as 1, that is in this case hash of 37 comma 1 it becomes 5. So in this way, how we can solve the collision problems. Again, for the key 59 at 0th index position, we got the value as 4. But 4 is already been taken by 26. So we are going for the first index position and we got the value 5. But again 5 is fixed. So we have gone to the second index position and we got the value 6. So again for 76 76 key value, we got the value as 10. For 65 we got 0. Again for 86 we got value 9. So this is basically my array and it is having 11 positions in it. That is, its index positions are from 0 to 10. So for the first case, that is 26, it will be at 4th index position, as we got the value for hash function as 4. Again for 37, we got the value as 5, so it will be placed as 5th index position. For 59, we got the value as 6, so we are placing the key value 59 at the 6th index position. Similarly, for 76, it will be at 10th index position. For 65, it will be at 0th index position, and for 86, it will be at 9th index position. So this is how linear probing exactly works. So let's move forward to the next point, that is quadratic probing. So basically quadratic probing is similar to linear probing, and the only difference is the interval between successive probes of entry slots. So basically the hash function for quadratic probing is h of k comma I equals to h dash of k plus c1 into I plus c2 into I square into mod m. So this is basically the hash function for quadratic probing, where h dash of k is k mod m and c1 and c2 not equals to 0. So let's move forward to the next point, which is double hashing. So basically double hashing is similar to linear probing, and the only difference is the interval between successive probes. Here the interval between probes is computed by using two hash functions. So the hash function for double hashing is h of k comma I equals to h1 of k plus I into h2 of k into mod m, where h1 of k is k mod m, h2 of k is k mod m dash, where m is the size of the array and m dash can be m minus 1 or m minus 2, and k is the key value. So this is what double hashing is. So this was all about today's session. Hope that you guys are now clear with the concept of hashing. So thank you for listening to the session. Thank you.